Today is December 13th, 2025, and the world of manufacturing is undergoing a transformation that is both profound and accelerating. The numbers tell a story that headlines often miss. In 2024, the global installation of industrial robots grew by an estimated 10%, a significant figure that builds upon years of consistent expansion. This isn't just about adding machines. It's about fundamentally rewiring how we create, innovate, and work. These statistics are not abstract figures for economists alone. They are the leading indicators of a seismic shift that will soon touch every community, every consumer, and every worker. Understanding these numbers is the first step toward navigating the opportunities and challenges that lie ahead. The scale of this change becomes clearer when we look beyond the sheer quantity of robots. We are talking about a convergence of technologies. It's the robot on the assembly line, but it is also the sensor that monitors its performance, the software that analyzes its output, and the network that connects it to a global supply chain. This interconnectedness is what makes the current industrial revolution different from those of the past. The growth is not just linear, it is exponential. Each new piece of technology amplifies the power of the others, creating a virtuous cycle of improvement and efficiency that is reshaping the very definition of a factory. This revolution is not happening in some distant future. It is unfolding right now, in quiet industrial parks and sprawling manufacturing campuses around the globe. While we go about our daily lives, these automated systems are working around the clock, producing the goods that fill our homes, the cars we drive, and the technology we depend on. The 10% growth in robotics is more than a statistic. It represents millions of hours of automated labor, billions of dollars in economic activity, and a tangible step toward a new model of production. It is a quiet but powerful force that is setting the stage for the next chapter of our global economy. To grasp the full implications of this shift, we must break it down into its core components. The changes are not monolithic, but are composed of several key trends working in concert: the raw power of new machines, the intelligence derived from vast amounts of data, the critical move towards sustainable energy, the evolution of human jobs, and the exciting new potential for customized design. The first and most fundamental change is a dramatic leap in productivity, driven by a new generation of sophisticated machines. A single modern factory robot designed for repetitive tasks, like welding packaging, can perform 2 to 3 times faster than a human without breaks or fatigue. This is a step change in efficiency. That speed directly lowers production costs per item. The economic ripple effect is enormous. More goods, less time, lower prices. Consider the automotive industry. A modern car plant can finish a vehicle in under 20 hours of labor, compared to hundreds of hours before. Robots now handle heavy lifting, precise welding, repetitive bolting with unwavering accuracy and speed. The second major transformation is the conversion of factories into immense data-gathering ecosystems. A single, highly automated factory can now generate millions of data points every single day. This torrent of information comes from thousands of tiny sensors embedded in every piece of machinery, largest robotic arm, smallest motor. These sensors constantly monitor temperature, vibration, energy consumption, output quality. This isn't just data for the sake of data. It is the raw material for a new kind of intelligence that makes the entire production process more reliable, transparent, efficient, turning raw information into actionable insights. Predictive maintenance is the best example. In the past, equipment was repaired only after it broke down, causing costly, unplanned downtime. Today, sensor data is fed into sophisticated software that uses AI to detect subtle anomalies. Section 4. The Green Shift. Powering production sustainably. The third critical change is a powerful and necessary shift towards sustainability and energy efficiency. Driven by a combination of economic incentives, regulatory pressures, growing environmental awareness, new factories are being designed to use significantly less energy per unit of production. Many modern facilities consume between 20% and 50% less energy than their counterparts from just a decade or two ago. This is a monumental achievement, representing a direct reduction in operational costs and environmental impact. A cleaner factory is a more profitable factory, creating a powerful business case for going green. This efficiency is achieved through a variety of innovations. Advanced insulation, energy-efficient LED lighting, intelligent climate control systems drastically reduce the baseline energy consumption of the building itself. Furthermore, the machines on the factory floor are engineered for minimal energy use. Electric motors with variable frequency drives, for example, only draw the precise amount of power needed for a given task, avoiding the waste associated with older, constantly running systems. These seemingly small upgrades, when multiplied across an entire factory, add up to massive energy savings and a significantly smaller carbon footprint. Beyond simply using less energy, the factories of the future are increasingly generating their own. Section 5. The human equation. New jobs for a new era. The fourth and perhaps most socially significant change revolves around the future of work. The rise of automation inevitably means that some traditional manufacturing jobs, particularly those that are highly repetitive and physically demanding, will decline. However, this is not the end of the story. History shows that technological revolutions eliminate certain job categories while creating entirely new ones. For every job displaced by automation, new roles are emerging in areas that require uniquely human skills: problem-solving creativity, technical oversight. The challenge and opportunity lie in preparing the workforce for this transition. The new jobs in a smart factory look very different from the old ones. Instead of operating a single machine, a worker might be a robotics technician, responsible for maintaining and programming a fleet of automated systems. Instead of manually inspecting products, they might be a data analyst who monitors quality control dashboards and identifies trends from production data. Other new roles include automation engineers who design and implement new robotic workflows, sustainability managers who optimize the factory's energy and resource consumption. These are higher skilled, often better paying jobs that involve working with technology, not in competition with it. The key to navigating this shift successfully is a focused and accessible approach to skills training. Short-term certifications, apprenticeships, and on-the-job training offered by companies and community colleges. Section 6. From mass production to mass personalization. A hopeful horizon. The fifth and final change brings all the other elements together, creating an exciting new capability: mass personalization. For over a century, the factory model was built on the principle of mass production, making millions of identical items to achieve economies of scale. The new generation of flexible, data-driven factories turns this logic on its head. Advanced robotics 3D printing technologies now make it economically feasible to produce small, customized batches of goods quickly and affordably. A factory can now pivot from making one product variation to another with a simple software command, opening the door to a world of personalized products. Imagine a shoe company that can produce a pair of sneakers tailored to the exact size, gait, style preference of a single customer and deliver it within a week. Think of a furniture maker that allows you to adjust the dimensions, materials of a table online and then manufactures it to your precise specifications. This level of customization strengthens the connection between the consumer and the brand and allows smaller, innovative companies to compete effectively with larger incumbents by offering unique and specialized products. Companies can establish smaller, more agile microfactories closer to their customers. This model reduces shipping costs and environmental impact, shortens delivery times, and most importantly, creates skilled manufacturing jobs right back in the communities where people live. It represents a move away from a fragile global supply chain toward a more resilient network of local production hubs. The convergence of those elements makes it possible for communities to reclaim a degree of economic self-sufficiency. This is not about resisting technological change, but about harnessing it to build stronger, more resilient, and more prosperous local economies for everyone.